Hello friends, as part of this discussion we'll be understanding percentiles concept and also quartiles. So these are two concepts we are going to discuss today, and we'll be also looking into some Python examples. So let's start. A percentile is a measure used in statistics to indicate the value below which a given percentage of observations fall. Let's take an example. If a score is in the 90th percentile, it means it is greater than 90% of all scores. So typically in competitive exams, results are given in percentile. So let's understand this concept in more depth. So imagine a class of 100 students, and if a student scores 85 marks, and this is the 90th percentile, it means the student scored higher than 90 students in the class. So let's say in that class 100 students were there, and a particular student scores 85 marks, and this is the 90th percentile. So the results for the student would be he or she has got 90th percentile, let's say. So it means the student scored higher than 90 students in the class. Related to percentile, there is another concept called quartile. So what is quartile? It's also a statistical concept. Quartile divides data into four equal parts. Let me bring the pointer. Yeah. So 25th percentile is basically Q1, quartile 1. So it separates the lowest 25% of data. 50th percentile is called quartile 2. This is the median of the data. And quartile 3, which is Q3, is basically 75th percentile, and it separates the lowest 75% of data. If you look at here, so this is the first quartile. So below this point, so these are 25% of the data, and this is lowest 25% of data. Then up to this point, this is Q2 median. So below this point, these are 50% of the data. Then third quartile, this one, Q3, 75 percentile data. So this is Q3. Below this point, these all are 75% data. Separate the lowest 75% of data. So these are the lowest 75% of the data. And above this point, these are the 25% of the data, which are in the higher side. So if you look at here, so Q1 25, Q2 again 25, and up to this point basically we are covering 75% of the data, and then rest 25%. And there is a concept called interquartile range, IQR. This is nothing but the difference between Q3 and Q1. The difference between Q3 and Q1. This is the range basically, interquartile range. Hope this concept is clear. We'll be discussing with some Python code. Practically, we'll be seeing how this concept basically comes into light. So with some examples, we'll see. Okay, so let's move ahead. We can use box plot to visualize quartiles and percentile, what we discussed in earlier slides. So I will come back to this slide later. We will see that what is the benefit of this quartiles and percentiles, how these helps to understand the data distribution, and also typical use case for box plots. But let's see some examples. We have some Python codes. So yeah, so this is an example data. So let's say I have these data points, and I want to see what is the 90th percentile here. So the 90th percentile value is 46. We can generate using Python code. So 46 is the value. So that this signifies 46. 90th percentile is 46. That means Below 46, I will have 90% data available. Similarly, quartiles we discussed Q1, Q2, Q3, three quartiles, 25%, 50 and 75th percentile. So 50th percentile is the median one, which is Q2. So these are the values. Q1 is 20, Q2 35, Q3 40. So box plot, using box plot, let's understand these quartiles. So this is the code to generate box plot. If you look at here, Q1 20, Q2 35 here, this is the median, and Q3 40, this is Q3. So this signifies below Q3, below 40, I have 75% of the data. Q2 below 35, I have 50% of the data, and below 20, I have 25% of the data. So that's how these values 20, 35 and 40, Q1, Q2, Q3. So that's how we interpret. And the values which are in extremes, like below these points, some dotted points would be there. This helps to understand if there are very high or very low values below these points. Some dotted points would be there. So these are kind of outliers, extreme data points. We'll see, going back to the slide, we'll try to understand how this helps. Now, if I also want to understand, suppose this is in data, so this data points are available, let's say. Now I want to see among these values, suppose I chose one value 80. So I want to understand in this distribution 80 belongs to what percentile. So if you see using Python code, we can understand 80 belongs to 90th percentile. So that means I have 90% of the data below this 80. So 90th percentile. So that means below 80, I have 90% of the data available. Let's go back to those slides. Yeah. So box plot helps to visualize the spread and skewness of our data. So how the data is spread and if there is any skewness in the data. Skewness is basically if the data is inclined to the towards higher or lower side. It's skewed towards a particular end, let's say. So maximum values, let's say, fall towards a particular side, let's say either higher side or lower side. So that's how this quartiles helps us. So if the median is closer to Q1 or Q3, then we can understand data is skewed. So it's skewed towards the median value is basically close to, let's say, towards a particular quartile Q1 or Q3. So these ends basically, this ends, if you see Q3 and Q1. So this median value, if it is inclined or skewed towards a particular end or close towards a particular end, that indicates data is skewed. So that's how this box plot helps. And also outlier. Outlier appears as individual points, as I was discussing earlier while showing you the Python code. So if you look at here, uh, these dotted points, so possible outliers basically. So these are extreme values, either very low or either very high. So these are kind of possible outliers. So that's how this box plot helps us to understand all these concepts, data distribution concepts. Hope this is clear to you. We have Python code available. So if you want to play with this code, you will find the code available in this Git repository. I'll be sharing this link in description so you guys can check out. Thank you.